Are we live? Yes. Okie dokie. Hi, everyone. For the ones who don't know me, my name is Mylène, and I'm the proud bookend manager of Wagon for the data science class 10-11. And today we're here for the demo day of our students. For the ones who don't know, it's basically the day where our students showcase the results of their hard work. They have been learning about data science, data analysis, visualization, machine learning, deep learning for the past 9 weeks. And the last 10 days, the last 2 weeks, they've been working on their final project that will be part of their portfolio. And yeah, we're very proud for them to be showcasing it today. But before we start, let me just tell you a little bit more about Wagon, which is the #1 coding bootcamp worldwide for the past 5 years. If you check the best evaluations online, and we're very famous for 2 programs. The first one is web development, where we teach people how to code and where they can become developers. And second one is data science. It's the one from today, where people can become data scientists, data analysts, data engineer after the bootcamp. And we offer both programs in a full-time or part-time format. But something new that I'd like to share, I think perhaps it might be new also for some students here, is that next year we'll have another bootcamp about data analysis. This one will be more focused about the business part of data science, of data analysis. So it's like not deep learning, for example, and more cloud visualization, reporting, that kind of thing. So this will be starting next April. So if you know anyone interested, please tell me about them. And I just wanted to mention also that a lot of people believe that after Wagon, you can only become a developer, you can only become a data analyst. And it's true that most of them end up doing this. If you're part of the Wagon email list, you might have received yesterday our outcome report, where we showcase all the Wagon students' jobs, how long did it take them to find a job, what kind of salary, and we have great results. I highly advise you to check it if you can. But actually, I just wanted to mention that also a lot of people end up doing something completely different. Like they work in the business part, for example, in marketing, growth, and they work with data, they work with code, or they have to work with people who code. So if you're interested in doing a bootcamp, please know that there are so many other opportunities than being a developer, being a data engineer, that there are a lot of jobs out there that we don't even know about yet. So yeah, I just wanted to mention that. And also our 16,000 students community all over the world. I know that in our class, we have either a lot of international students or like even Brazilians living abroad. And I just wanted to remind you, please, please, please take advantage of this community, okay? In every single city, we have a lot of events happening. Please go network with them, go ask for a job, go ask for an opportunity to show your new skills, because these are 16,000 students over the past 8 years. So a lot of them did the bootcamp, became project manager, became CEO, CTO. So it's a big network, it's a lot of opportunities, and all you have to do now is seize them. Okay? Don't give up on Slack after the bootcamp. There are a lot of things happening there. But now it's time to showcase the stars. And before that, I just wanted to remind you of some beautiful memories we shared together at school, online, at the beach. Our mascot of the class, the dear vieram. And a big thanks to our sponsor for this class, coffee. 780 cups consumed, more than 18,000 euros spent, and we still don't know if there was much productivity added, but we still had a lot of fun. So thank you so much to the coffee for sponsoring this class. Are you guys ready now? Ready to roll? Look at Eduardo showcasing the sponsors, see? We're not even getting money for that, but they're everywhere in this class. Okay. For the first speech, I will be calling Silver Tone. Are you guys ready? Ready to roll?
We are.
Yay.
Should I start sharing?
Yeah, let's go.
All right. Can you see my screen? Is everything okay?
Yes.
All good. Okay, so our project for this final project in the data science 10-11 batch was Silvertone, which is a pitch perfect tone recognition, right? So it's a tone recognition model for audio and recorded audio. So basically, when we're talking about language and when we're talking about communication, we see that tone is quite crucial to understanding, right, language, and to be able to communicate effectively with other people. And sometimes even more so than words themselves. We've all been in situations where people were saying words, but they didn't really mean those words, and you had to kind of read between the lines. And the thing is, tone isn't really structured into semantics. It's structured into prosody, right? Prosody, which is basically sound and structure of an audio file or an audio emittance. But the thing is, while machines can quite easily understand, or somewhat easily understand, what is being said, so words and language and the semantics of it, they have a very hard time understanding how, right? Because it's something that we as humans are very fine-tuned to do. And if you can't hear either permanently or temporarily, or you lack the ability to read context and tone, you also lose that dimension. So basically you have a functioning like a machine, or you lose this extra dimension of language. So that was the idea. That's where we came in. We tried out quite a lot of different models, from machine learning models to deep learning models. Each of us tried out 4 or 5 models. It was basically, that was basically the core project for us, right? Trying to structure our data and our models to understand how humans actually speak. And to do that, we use university databases, usually composed of actors being given emotional prompts, right? So images or ideas, or just act this out in an angry manner. So basically they repeated the same phrases over and over in different emotions, different actors, different genders, just this huge database of different emotional states without relying on semantics. So the phrases themselves weren't really that important, which is important to understand the model. So the result was models with 60% accuracy, so they can understand it 60% of the time, and that can both understand emotion and transcribe it to text. Because as I mentioned, it's quite a bit easier, and there are lots of existing packages, right? And just before we go to the actual demonstration, just to introduce basically what we're talking about when we're talking about sound. This is what we call a MEL spectrogram, which is basically a visual representation of sound, which has in the y-axis the hertz, so basically the frequency, which would be the tone, A, B, C, A sharp, B flat. All of these are tones that can be represented in hertz, right? And in the x-axis, that's time. So basically, what we're doing here is we're plotting frequency against time, and the colors represent volume, so loudness. So the darker color, the louder it is. So where are we structuring? Like, how is the speech structured? Where are the focal points? Where is the energy concentrated? And this is basically what we analyze when we're talking about tone and audio. So the thing is, currently this is very theoretical. It's a very university-focused field of study. We've seen this also being done by Google and Amazon and in speech recognition in order to be able to create speech generative models that are closer to humans, right? And that can understand human emotion. So just a few applications that come to mind. So this human-machine interface, more expressive auto-transcription, so you can transcribe both the text and the feeling behind it in an easier manner, identifying distress. In, for example, a police situation, or in airports or human trafficking, just this emotional thing where you can kind of understand distress in speech. And as I mentioned earlier, accessibility, right? And now for what everyone was waiting for, let's go to the app, right? So we built an app on Streamlit that basically hosts our model online. We'll send you guys the link afterwards. We'll post it on YouTube. So basically, what we can do here is that we can click this button and see the app do its magic, right? So, oh my God, it's so nice to, one sec, guys. Oh my God, it's so nice to see you. How are you? Treating me as angry, quite a high energy phrase. It's not perfect, but what it brings here is first, an emotional identification. Second, a transcription, and third, the spectrogram of your audio, right? So what was actually recorded? And you can try it out with different emotions. We have quite a few. Let's see if it works this time. I can't believe that you're talking to me like this. Honestly, what is wrong with you? And it reads the opposite. So it's supposed to be happy. Not a perfect model, but in the end, we managed to get in with better microphones and more controlled environments, perhaps, better results. It's around 60% accurate when we're talking about the train and test. It is a huge field and it can be further developed quite extensively. But this was our minor contribution. And if you want to look into it, we have a link to the repository and to all our GitHubs. And we'll probably keep working on this project afterwards because we loved working with audio and we love working with emotion and speech. Thank you very much for being here and for the attention. And good day to you all.
Woo! Congratulations, team! Yay, everybody clapping.
The goat, the goat.
Great work, team. The goat. I hope you're proud, team. Great work. Feel free to send the link, any links on the YouTube chat, okay? For the ones who are watching and who might be interested.
I did. I did. Perfect.
Awesome. Guillermo is on it already. The goat.
We have our MVP on the job.
Perfect. Okay. Without any transition, I will be calling Diego with Super Energy Predictor. Are you ready, Diego?
Yes.
Yay. Go. Ready.
Yes. So, good morning, everyone. We are happy to present the result of our enterprise. So we present you the Super Energy Predictor. So our motivations are initially, first of all, can you hear me well?
Perfect.
Yes. Yeah, sorry. So our first motivations are first environmental. So energy and environmental issues are very, very strongly connected for good and for bad. Energy is a great part of the impact on climate nowadays, but also is great part or the most promising part of climate change mitigation. And another motivation for us is geopolitical. So energy and energy prices, if you notice in the last year, there was a huge spike on energy prices because of geopolitical reasons, on the war on Europe. So energy and environment and energy consumption are our motivation for this project. Initially, we wanted to answer some questions. For example, if you walk on the streets and see like this huge skyscraper and you ask yourself, how much does it take to make this skyscraper cool in the summer? Or how much can I save by living in a sustainable building? Or how can a company improve energy efficiency in future building projects? Also, we see every day a lot of investments done in retrofitting buildings to improve energy efficiency, but are these improvements working? So we present you the Super Energy Predictor. That's basically a management tool for energy efficiency. And our starting point was this challenge on Kaggle from Ashray, this company that works in this area, and they find this probably to improve their product. So it's real data, real applications, and we use these data sets and all the discussions and from the community that came from this challenge to improve and to make our product. So our steps to bring to you guys the web app were basically the back end and the front end on the left side. Just to summarize, we decided for a light GBM model that has a very good cost benefit. So by cost, I mean memory usage, and by benefit, I mean like the results, the accuracy, and the square errors. So we opted for light GBM. On the right side, we implemented an API, 3 modules that we will demonstrate to you, and we designed an interface on Streamlit. So we'll jump to the page, the web page. So we can share the link with you guys. So this is our web page. We explain a little bit the idea of our business, the technologies you use, and as a short guide to this app. So initially, this first module here is made to predict energy consumption for a building that you are interested in. So let's suppose I'm the manager. So it's a long, to make a long story short here, we could get from other sources some of the locations, but this was not available in the first data set, especially public locations. So you see here some cities, some universities, but these are only the public information available to make it more concrete for you. So let's suppose I am the manager of University of California, Berkeley, and I have a lot of buildings to manage, and the energy bill is huge, and it's very important to know what will be the future consumption. So let's suppose this building here that exists, but let's suppose it's the Department of Neuroscience, and I want to know what will be the energy consumption over the year of 2017. Just to remember, we trained our model on 2016 information, and 2017 would be the future. So we have weather forecasts, we have building characteristics. So first of all, when we try to predict here for electricity, we'll see a short summary of the building, so the size, the year built, the purpose of the building, and the energy consumption over the year, and the energy efficiency in kilowatts hours per square feet. And also we have here a graphic representation that we can go through different forms of presentation. For this consumption, this is over the year, so it can change for monthly consumption, daily consumption. And then we go to the next step that, in our opinion, one of the most promising modules. We like it very much, the idea behind it. So let's come back to that first building, just to use it as our, so building 656. So let's suppose I have this building there is a department or a hospital, or you can think in any purpose, and I want to do some changes. So for example, I don't need that much space anymore, and I want to join two departments or whichever the reason. So I will change the proportion, the size of the building, and then I will see what will be the difference in energy consumption. So see that, of course, less area means less energy consumption, but let's simulate something else. Let's suppose we want to change the purpose of our building. Just give an example that is kind of random, but let's suppose I want to transform in a parking lot, or if I want to transform in offices. So what would be the energy consumption by changing the purpose of our building? And in the end, I will also introduce a little bit of what we can improve here if you have more data. Finally, this module here is to compare two buildings. So let's suppose I have a reference building. Let's suppose I have an organization, a labor organization that says like, this is a reference building in terms of energy consumption. How are you performing compared to this reference building? So in this case here, we have the full values, but we could put any building here and compare the energy efficiency of this building that we are inputting with the reference over a specific period of time. And then we have as an output, just a minute, December. We have as an output, a graph can be accumulated. So we see that this building that in blue, the first one here, has a much higher or much lower efficiency. So the less the energy consumption, the higher the efficiency. And we can do this with any building, for example, if you have a retrofitted building before, and you can see what's the difference in energy efficiency. So this is our product. We have a lot of space for improvement to make it even more interesting. So for example, if you have more information on the wall materials of the buildings, on other characteristics like position in relation to the sun, and many other things that unfortunately the company, maybe for commercial reasons, wasn't able to provide. I think this product, we can do many more things. But this is the basic idea. Thank you so much for your attention. This is our team, and we can send the link also. This app is on the cloud, and any questions you can reach us. Thank you very much.
Woohoo! Great work, Diego. Best performance.
Good job.
Even have people commenting on the YouTube chat about your app. I'll send screenshot to you later. Great team, great work. And next group now, I'll be calling Code Authenticity Detector. Are you guys ready? Final stress, final sprint.
Can you see my screen?
Is working. Yes.
Can you hear me?
Yes.
Yes.
Great. Let me just move for it. Okay. So we would like to present our project, which is called Crosstrack, actually, which is about source code stylometry and authorship attribution. 1 second. Yeah. So stylometry is defined as the statistical analysis of variations in literary style between one writer or genre and another. Beyond literary style, it has also been applied successfully to music, fine arts, and more recently to code. I don't think I need to define source code for anyone here, so I'll just talk about our project. So what we're going to present here is our attempt at building machine learning and deep learning models for the purpose of predicting the author of a certain piece of code based on these stylometric features. So here is our problem. Can we actually identify the author of a piece of code based solely on its style? And I'll spoil you the surprise a little bit. We can. And for what purpose, you may ask. So for example, it could be to evaluate the proficiency of a coder. If you're hiring, you're looking for senior developers, you want to make sure the person applying is a senior developer, writing his own code. It could be used in the forensic field to identify the author of a code that was used for nefarious purposes. It could be used by universities and schools to detect and make sure their students are not plagiarizing from somewhere else. Now I'll tell you about our data set. So our data set comes from Google Code Jam, which is a very famous coding competition where coders are challenged to solve problems in the best possible way. They have on average 700 coders that take part in this competition every year. And so for this project, we try to get as much data as possible. And we have about 100,000 samples of code from 2008, when the competition started, until 2020. So in each row, we have the sample of code, which is associated with its author, which is going to be our target. We had to do quite a bit of research when we set up the project, and we found that there was quite a few papers where people tried to do this. And in most cases, the attempts were language specific, meaning that they were trained only to do this, but on C or Java, but not on a variety of languages. And apart from maybe one or two exceptions, the accuracy in those experiments usually dropped quite a bit when the number of targets was increased beyond a certain threshold, like maybe 50 or 100. So we defined our two main objectives for this experiment as such. It was to create a model that would be language agnostic, meaning could deal with multiple language, then have to be trained on individual language, and a model that would be able to handle a really large data set with a really large number of targets. In our case, 1,500 targets. So it's a classification problem with 1,500 classes. And I will give the word to João. Sorry for the spoilers.
Okay, thank you. So basically, we were quite happy to find some very good resources on our research, and so they managed to give us some good reference of how to pre-process our data. So just to be clear and show you guys a little bit what we did here. Just like then, we've selected only the three most important languages. They make up about 85% of the entire data set. However, they did consider any sort of code that was inputted, even source code that only contain like 5 characters long. So we thought it would be easier, it would be better to select top quality samples. So we came up with this range of 500 to 1,200 characters. We thought it would be. But we thought we ran some analysis on, which is the average length of code of the finalists. So people who really wrote quality code. And also we tried to be a bit more conservative and keep only 9 samples per offer for the developer. So we could feed our model with less noise and more samples. And then one interesting thing here I'd like to mention with you guys, we talked so much about NLP during our lectures. The authors of these researches, they weren't able to deal with some code that was nearly duplicated. What happens is sometimes Google would ask a developer to write a second exercise that required code from the first exercise. So it's basically, a large percentage of the code would be just the same. So we managed to remove these near duplicates using a Liebenstein distance algorithm. That is pretty cool. And if you guys are interested in looking into it, we can show you later. But what it basically does, it pinpoints code that look too alike for the same code offer. So we managed to remove that and provide our models with a much cleaner data set. And right, so and then we went on to do some training. Just like we had presented to you guys a few models we would like to see. We tried recurrent neural network, which was the most expected model for us, and it wasn't the most positive one. We tried naive-Bayes, we went on with the SVC. They all presented very good results, and whatever is, we think it's above SVC, it's really good results. But eventually we found out the convolutional neural network outputs the best accuracy. It's as good as we found in these best articles that we had. And the nice thing here is that it's also we managed to create a model that is agnostic to code. So it basically runs on any source language. And also we managed to create a very light model that also how do you say, it can receive so much input as large as those largest data set, something around 1,500 authors of code. So we'd like to show you guys. Tim's going to give you a quick demo of an app that we've created.
Perfect. So I am going to take over from here, and I am the lucky guy that can show the app we created to you. Only lucky if it's going to succeed. Let's see. So this is our front end. And you have a lot of different information about it. So we tried out different models and we incorporated in the top of our front end. And for each of the models, we give you a tiny description about what it's actually about and what does the model do, what makes it special. And afterwards, we give you some information about how we use the model. So what were the processing steps? What was our pipeline about? To give you an information to what steps our data took to actually come to a result. And to give you a demo, we just take the CNN model, and it works in the way that we enter some piece of code below. And to showcase how it works, I took two different pieces of code. The first one is actually a piece of code I wrote. So let's see what our model actually predicts. It'll take some time. No worries, I'm very confident we will get a result. There we go. So we got a prediction, and this name we see here, it's the prediction of one of the coders of our Google CodeGem dataset. So it seems that our model found out that my coding style is actually the most similar to AED, Aiden Poe, maybe. But if we when we have a look at the probability, we see that it's actually quite low. So we can actually say from this graph that our model gave us a result that the piece of code I gave it is actually not similar to any author from the Google CodeGem dataset. And in the very bottom of the page, we see the terms that our model used to actually get to this conclusion. So these are the 15 most important terms used by the model to come to this prediction. And for the second prediction, I actually have a piece of code from the Google CodeGem dataset. So we are going to do another prediction. So now model, again, did a prediction with the other piece of code. And here we can see that the predicted author is Alan Cheng. And in this case, we see that the probability of Alan Cheng being the author is really, really high. I have a small suspicion that our model saw the piece of code before, maybe. But maybe it's also just because our model is amazing, and we will not find out today. And these are the most important terms that our model used to come to this prediction, and to actually say that the piece of code we gave to it is from Alan Cheng. And I know there's a lot of people having questions now because it's a very, it's a complex path coming to the prediction. So maybe, for example, Guillermo asked himself, why do we actually use the TF-IDF vectorizer instead of others? Or Edu asks, how did we actually train our model? And I'm sure there's a lot of people who are very interested in seeing the source code. So you have all of those informations here in the FAQ. You can have a look at it and try it out on your own. And with that, I give back to Joao. Thanks. Can you just share?
Oh,
Yeah, so
it's not over.
we got
Oh.
we got quite
Also loud.
happy with the So we got quite happy with our final results. I mean, we managed to get a very good score. I mean, really, really good. I mean, close to the best research we've seen, and we didn't think we could achieve that much. There are a few learnings that I'd like to share with you guys. So using term frequency, what we call TF-IDF, was super interesting in our case, other than using tokenizer, which I'm sure you guys remember from our classes. We can talk about it later if you have any questions. And what's interesting here is that CNN suited our data sets a lot better than regular NLP models. And if you think about it, it's as if we were analyzing code as if it was an image, which is pretty cool because if you're almost the same as your brain, like looking at two pieces of code and telling the difference in style in both of them, and then being able to tell who wrote which. So what we're doing here, we're actually applying a CNN, a visual analysis model to text, and it worked just as well. So this is pretty cool. And even with what's nice also is that even with the full data set, we managed to get an accuracy beyond our expectations. This is mainly due to the combination of the TF-IDF and the CNN model. So I think it was pretty interesting. I was quite happy to be working with these guys. We had a great time. I'd like to thank you all for the presence, and for being together through this last weeks. Thank you so much.
Yes. So much emotion. Great tension build up. Okay, team. Next, last but not least, I will be calling Blast from the Forecast. Are you ready, Tim?
All right. Hello, everyone. I'm going to share my screen now. Let me know if you can see everything. Can you guys see my screen?
Yes.
Okay, good. All right. Hello, everyone. This is Blast from the Forecast. That was the name for the project, but our tool is called Tool of Thumb, because the idea is so we don't have just a rule of thumb when you're doing forecasting, because that doesn't work most of the time. And then so the idea is to present you guys how it works and how do we build the tool, right? So this will be our agenda today. We're gonna pass through our the meeting with the team. We're gonna pass through our goals from the tool, our product, and also the tool demo that we're gonna see how it works with the online, how we can do the visualizations of our predictions online and the forecasting. So this is our team. It's me, Eduardo Ferraz, and Thomas de la Fuente, Danilo Clemente, Mateus dos Santos Silva. I want to thank everyone that participated in the project. It was great working with you guys this past couple of weeks. The beginning was rough. We thought we wouldn't make it because we got stuck in some parts, but I think that's how it works, right, with these projects. And then I want to say special thanks to Ellen. She really helped us at the beginning of the project and kind of got us unstuck. So that was pretty good. And then we managed to have a successful project. So our goals for this project was we wanted to create a forecasting tool that could be adapted to different companies, right? So we want to create a package tool which will be able to do forecasting, and then we can package this and then sell to different companies, or if you're going to work in a different company, you go to the company and then do adaptations and can use the forecasting tool in those companies. That's the idea of the project. Why? We want to support medium-sized companies to have an accurate sales forecast, because large companies, they usually have like very specific tools. They have like tools that are very expensive. Actually, they're not always great, but they are expensive, and they have corporate telling them to use those tools. And then small businesses don't have enough sales, or maybe the idea of the money. So the idea is to support the medium-sized businesses. And this will be the idea of the tool, how we work in the market. So basically, we have the tool built. Well, that's not finished, of course, but the idea is to, once is the whole package, the first point here, we adapt the tool for the needs of the client. And then after that, we go into a cycle where we can do the data interface, process the data, run the models, do the fine tuning, and then have an output analysis. So this could be a one-time thing, a one-time sale. We can come to the beginning of the year and say, I can predict the next 3 months for you, or the year. Or this could be a recurrent project where you can stay in the company and then do a contract where every 3 months you come back and run the tool again. So that's the idea, how you can push this tool into the market and sell it as a consultant, or just sell the tool itself. Then you have to train the key users, but that's the idea, how we can put this tool into the market and put it in up and running. So our product, we had a great haul of 10 days. Usually if it was a normal project in a company, this would be months, right? So it's 10 months to develop this tool, but we had 10 days only. So we had this set up here for the first couple of days. Then we built the pipeline, and then we focus on the interface here as well. And then we prepared yesterday and today for this go live, which is the demo. And then this was the tools, the models that we used to compare. So we did a lot of studies and analysis at the beginning of the project. And in the end, we came up with a short list of two models that we can use, which is the Profit, Facebook Profit, and the LSTM, which is a deep learning model. It's a long short-term memory model. And these are when we start building the advantages and which one is best in which. So Facebook Profit's easier to set up. LSTM was really hard. The Facebook Profit gave us a more accurate output, so it was a bit better. They both run a good speed, considering what the outputs are. For the Profit, it was really hard to see the parameters and adapt, and whether the LSTM was easier. So this is a plus for the LSTM. And they both work with time series. That's what we needed, so we work with those. So this is the tool structure. This is what we have behind the scenes, under the hood. This is our package. So this is always part of the package that we have on the system on Python. So basically, we load the packages from the client, we load the data, we do the pre-processing, we define and run the model, and then we export the results. So this would be what's be doing the background with our tool. That's our structure. It was pretty good because we have a fast data interface. So we work with to train our model with a database that has over 2.9 million rows. With the columns that we had was over 40 million entries for the database, and we managed to put that as a SQL and SQL interface. And even with the SQL and this huge data set, we had, like, if you look here, we can load the data in 30 seconds to our model. So we can just load the data to start the pre-processing. So everything is live in this model, especially for the deep learning model that we connect everything. So that was pretty good that we have a fast data interface in case we want to work with remote clients. So for the deep learning model, what we used the LSTM, like I mentioned before. And in this model, we actually had 42 stores that we had to predict in 5,100 items. So we had to predict how the quantity of those items is going to sell in each store. So that gave us approximately 272,000 predictions that had to come out of the model. And we managed to do all that. We managed to do the pre-processing and put the model up and running. And that model runs in 90 minutes, so about an hour and a half. It might seem like a lot, but you have to remember that we're doing 270,000 predictions at once. So it's pretty good, actually, for the time that it gives us, and gives us the prediction for each item from each store. So that was a pretty good, interesting model, and I'm really happy that in the end it worked out. And then the other approach was the machine learning, so the Prophet. In this case, this Prophet, it runs with a consolidated data, so we didn't get the predictions per item, but got predictions per stores and per categories. So we have 42 stores as the one previously, and we have 62 categories where the items are consolidated into categories. So we got consolidated predictions, meaning we have the curve of prediction based on the categories in stores, which is also really useful for the companies because sometimes they don't need to go to the bottom level to predict their sales, but they do consolidate it. So there was a different approach that our model is also doing. And this runs pretty quickly, between 7 to 15 minutes. So that's also a plus, because this one you can plug into the interface online and you can actually run the model live because it's running pretty fast. So basically, and then in the end, we have a little analysis here, like strengths and weaknesses and opportunities, the SWOT data. So for the LSTM, we have fast predictions. The Prophet has a more accurate forecast. With the weakness for this project here, this part is like if you have low volumes, it's not going to work very well. And then mainly we have the good opportunities here to do online sales and model tuning. And then we have the threats, which is like it's hard to get the companies to perceive the value of the product. And then new technologies can come along as well and then make it obsolete. So these are the next steps. We have the integration that we wanted to do a bit better. We want to package the model. We want to have an interface improvement from what we are looking at now. We want to test new models, and we want to have also a report, build a report from the interface. Okay, so this was a project, and then now we're going to go to the tool demo. I'm going to hand it over to Thomas, who's going to show us the interface and the results of their project.
Hello, everyone. I'm going to share my screen. Everyone seeing this one? Yes?
Yes.
So we have the Streamlit. In the first page, we can have a preliminary view of the data set. So here we can see the total sales from our store. What we're analyzing, we had a lot of stores that sell like computer games, video games, and they have a lot of stores, a lot of categories. Inside those categories, a lot of items. So in the first part of the presentation is just to show the total number of sales from our stores, items, and categories. And we can see that by day and by week or by month. And you can see the item count or the value of the sales. If you want, we can see at the shop level, we can choose one shop and compare how they performs along the month. And here we can see aggregation of all the shops, which shops sells the most. And we can do also, you can see by there's something wrong with the category. I think I changed. There was a typo in the name and I changed it, and it's probably not finding it's not finding the file. But okay, the item is working. We can do the same thing with the items. We can by week, month, or day. It's a funny thing that the problem is some items just sell. Let me check. Just I have one here, 3731. This one. This is Grand Theft Auto 5. So the problem with the data, it's difficult to get a time series because we have when the game is launched, we have just a big spike, and it don't sell a lot. And we have like another one like this. In the future, we're gonna have to. It's a corporate T-shirt, and it sells the whole year. But from this data, we can see a data service, and the corporate T-shirt is one. It probably goes with other stuffs when they sell. That's why it's so big. And categories by shop. This one is just we look at individual shops and see which categories are sold in those shops. There's no model here. We're just showing the whole data. Here we do the validation of the model, the cross validation. So just here is the profit model, the whole project, but we can see here better this one. We have this one is our test data, and here in the end, the orange one is the test, and the gray one is the project, and we can see that they follow a similar trend. And all this analysis is for the whole of the data set, all the shops, all the items. Here we can see the trends. The trends is getting bigger during the whole data set. You can see that we have a weekly trend, especially under the weekends, and we have an annual trend. In the end of the years, everyone's go to buy everything. And here we have the metrics for the cross validations. It's so for some metrics it's low, it's a low number, but really low number. But if we check mean square error, it gets really high. The number. The forecast is I hold them. We run the model for all shops and all categories, so we can same problem with the category. I try to fix. But we can select a shop and see how it get the sales, the projection, and the test. And we can see the profit model above here. And in the end, we have the point was we were trying to predict the shops items, the items per shops during the whole for the next month by the data set. But it was really difficult because some items don't sell that much. So in the end, we try to make like a aggregate of all items. This is the prediction of sales from the next month for the whole data set. Each prediction is different because the first one is the whole data set. The second one, I did all the shops individually and then made a sum all the together and get the category. We can see this is the prediction, and you can see the prediction for each shop. So next month, the shop 31, we expect to sell 7,000 items. We can see for categories, category 20 is PS4 games, and category 30 is PC games. We can see how many items on that category we expect to sell. We can see distribution by item. 3731 is Grand Theft Auto 5. The item we expect to sell the most. And this is more discrete data. We're showing that category in that shop. So here we have the shop 12 and the category 9. Category 9 is delivery goods. But if you look at well, in the second line, 55, 34 is payment cards, and then if you go to the other ones, you see 40 and 20 are PC games, PS games, and stuff like that. So that's basically all I have to show from the Streamlit.
Yeah, so the idea is to have the interface now that's more interactive with the customer. He can choose the name of the product, choose the store, and see everything together. Our name is from their database all in Russian, so we translate it a little bit, but we're not sure if it makes sense because none of us know Russian. But yeah, so this is the idea, is to put it up here and have the person who is working for the store or the department of sales or department of supply chain or the money planning have a report from this and be able to plan the whole supply chain. That's the whole idea of the project.
Yeah. Mm-hmm.
And I think that's it.
That's it. I'd like to thank everyone for the project, and that's all. Thank you.
Thank you. It's already over.
What? Oh, sorry.
Okay, guys, congratulations. It's the end already, but it's not really the end for you. Dun, 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 dun. Congratulations again to all of you. I hope you will enjoy your week of rest next week. And we're coming back next week with some career workshops, and in January to meet companies. Okidoki. And congratulations to the teachers also for this great class. Aniel, Lucas, Andrea, Mauricio, João, Livia, Alexandra, Amanda, Plinio, and all the other ones. I know that you will be missed by the students once they will not be able to open tickets at work. I hope students can give you a warm thanks. And yeah, thank you so much for your work and your dedication. Le Wagon doesn't have any value without you. You make the Le Wagon value. And again, if you want to know more about Le Wagon, about our next events, follow us on LinkedIn, Instagram, everywhere. We have a lot of things coming up. And congratulations again to all the students. And now we can start the online happy hour. And thank you to the YouTube public. Ciao, ciao.
Barbecue now.
Congratulations.